Okay.
We are now back.
Part 3, and we're finding T1 and T2
1, 2,
on the
3.
tension in this picture. So far, we have T2 cosine 135 plus T1 cosine 45 equals 0. Let's improve on that. I need, Emily, if you would give me the cosine of 135.
Negative square root 2 of 2.
What is it?
Negative square root 2 of 2.
Alright, but I need a fraction. I mean, I need a decimal,
Oh,
so just pull it out of your
goodness.
calculator.
Negative 0.707.
0.707?
Yeah.
Okay.
Negative.
Negative from cosine 135. So I
Right.
bet if you put cosine of 45, you're going to get a positive.
Yes.
Alright? Let's
Wait,
solve
I'm just doing units.
Oh wait,
But
what do we have to be in degrees?
degrees.
Okay, then we're good.
Because you see, I should have the little degrees to remind you. These remind you where we are. If I had had pi over 3, you would have been in radians. Pi over 4 for 45, we would have been in radians. Alright, so I'm solving for either T1 or T2. I'll move T2 to the other side of the equation because that everything will be positive.
It's a lot of numbers.
I'll put 0.707 T1. I'll put the 0.707 in front, it just looks nicer there. And I move, by addition, the negative 0.707 T2 over here. And I continue to solve by dividing both sides by 0.707. And when I finish, I get T1 equals T2. So that's not very helpful, is it? But they won't always come out this simple because we won't have the same angle on most, the next one we do will have different angle. But this is good starter problem. So I've got T1 equals T2, but that's not any kind of answer. So now I'm going to go to the vertical components and work there for a while. Again, the sum of the forces in the vertical direction are 0. So this is vertically because the object is not rising or falling. So what are all the forces? Well, you know because you colored them all already. They are the mine are blue, yours are whatever, yours are. So I'm going to start adding those. T2 sine of 135. I'm grabbing this one first. Doesn't have to be, but these three are going to be in this part of the problem. Plus T1 sine of 45. I'm going to start over here a little so I can fit it on one line. T2 sine 135 plus T1 sine 45 minus the weight, 50. So I'm just going to put minus 50 equals 0. You see there are 3 forces that I have to add together on this one. All right, Alex, could you tap out sine of 135 for me? I need the decimal form.
Minus 50. It's negative 50.
Sine of 135.
Yeah. Sorry. Oh, sine. Okay, I did the entire thing. All right. Sine 35 is 0.09.
Point
Are you doing the
0.
right thing?
Well, maybe
Are you
it's.
radians?
Look at your mode.
Oh, it's saying eternal radiance on me. Dang, nabbit.
Okay.
All right. Sine 35. Is it 0.7?
All right, 0.7, probably this number
Yeah.
again.
Yeah.
All right, so 0.707 T2. All right, so sine of 45
It is 0.7 again.
All right, 0.707 T1 minus 50 equals 0. So let's start going down this rabbit trail, and hopefully it will lead somewhere where we can use this and solve. So what's 0.707 T2? So let's move the 50 over. 0.7 07 T2 plus 0.707 T1 equals 50.
550 by each side? No.
And now I can't go a whole lot further because T1 and T2 are different terms. I can't add them. And so I can make this substitution though. That will bring me home. Everywhere there's a T1, I can replace it with a T2 or vice versa. I usually keep my T1s. So everywhere there's a T2, I'm going to put in my T1. It doesn't matter which way we go. So here's the T2. I'm going to make this substitution. Alex, now I need 0.707 plus 0.707.
It's 1.414.
1.414
Yep.
T1. When I add 0.707 T1s plus 0.707 T1, they are like terms now. I get 1.414 T1 equals 50. Last step, divide both sides by 1.414. So Alex, 50 divided by 1.414.
50 divided by 1. It equals 35.36.
Alright, 0.4 what, 6?
Yeah, 35.36.
No, 36.
Yeah,
I'll do
36.
35.4.
Yeah,
then.
it works anyways.
And that is newtons.
Superb.
Newtons.
Did you catch that, Hunter? Write it down.
We have come up with T1 is 35.4 newtons, so if we should be working in a number of sig figs. I guess we have 3 here. I never knew what to do with angles. So I'll go ahead and keep 3 and be happy with that. So T2 is, because T1 and T2 in this problem are the same. Does that surprise you? Did you think that because it was a 50 Newton weight, that the tensions would be 25 and 25? Did you think that?
Since it's in
It
the
would have
middle,
been if they were straight. Why is it now that this one has a tension of say 35 and this has a tension of 35, if we added it up it's 70, why was it more than the 50? Why does it take more tension when we're like that?
Because then it's the wall pulling. It's like,
The wall?
or whatever you're hanging it on. It's like.
It's
pulling it
actually
out
because
further
when
down.
I'm vertical like this, I don't have any horizontal to overcome. But once I go like that, in fact, every year I bring in a picture. I don't have one, but like if this was the picture and this was the tension, if you hold it like this, it feels lighter than when I go like this. So once I go like this, adding a component, a horizontal component, I have to overcome to suspend the picture. So that's why it's more. So think about that. It is true. All right. My goal today is to start another one and get you in a place tomorrow where you can do them by yourself. The one we're going to do next, they're not going to be equal, the 45 and the 45. So how many minutes do we have left? We haven't had the 5-minute bell, right? So
Nope.
we're doing fine. All right. Let us suspend something else this time. Let's suspend the flower pot.
We have 10 more minutes.
Okay, we'll get started. We probably won't get through it.
Should Alex restart the video?
He did a couple times already, so you're timing it, right?
Yes.
Okay. All right, draw a flower
So
pot.
the zoom in will be great.
There's Adam Keen, she's a savage. There's Zach, it's a savage too.
Give room to put some tension
Yeah,
above the
habitats.
flower pot.
Now we're drawing a flower pot.
Yeah, look at like one of those.
Look at that technique in the wrist. She draws a flower pot. Gotta add a commentary to it. Make it more vibrant, you know.
All right, flower pot.
Like,
And then there's Brandon.
This is a 5 kilogram flower pot, so you may mark it as such. And we're going to put in one tension wire that is 30 degrees, and the other tension wire is on this side is 40 degrees.
your phone top is hanging cockeyed.
So these dotted lines do not exist. I just put them in to show you the angles. they do not exist in the view of the flower pot. All right, so let me extend this. I'll put a ceiling. Say it's like a porch rafter or something that we're suspending it from. I'll call the tension in this longer wire at 30 degrees. I'll call it T1. I'll call the tension in the shorter 40-degree wire, tension wire. I'll call that T2.
Oh,
All right.
okay,
Let's see if you can take those two colors.
It makes sense at all.
See if you can take those two colors that you used previously and draw in the horizontal ones, the horizontal forces in this picture with one color. And how many do you expect there to be? And then draw in the vertical forces in this picture. How many do you expect there to be? All right, draw them in. If you can label them, go ahead.
Luke 1.
I'll put
36
arrowheads
to
on
what?
my tension wires because it's always away from the pot or the thing being suspended.
Well, I drew my entire pictures out. With the side.
All right, did you remember to draw the third vertical one? For me,
Yeah.
it's blue. Probably that's the spot where students miss the most, is they forget the tension, the weight. They remember the two parts of each tension, but they forget there's a weight involved. So there are usually three that are vertical, two that are horizontal. Put in the names of each of the forces. For example, I'm going to call this one T1 cosine 30. From that reminder, name all of the forces.
Look, that's cosine 30, the other side's cosine? No. No, that's cosine 40.
Yeah, over
Cosine
here,
40.
we're not going to use 40 though, because we're going to put it on a coordinate plane. And remember, we start measuring from here, so we go all the way over to there. So instead of 40, we will call it 140, because all the way over to the flat, straight line is 180, so we stopped 40 short. So 180 minus 40 is where it really is. So, over on this side then, we have T2 cosine 140. Remember the last problem we used 135, it was a different angle, but these aren't the same. Alright, so the blue ones go in next. So did you, or are you getting T1 sine 30 on this side, and T2 cosine.
That's the sound when
I'm sorry,
we are going on
sine.
commercial break into the safari.
Is that the
And we'll
another
return.
10 minutes?